Alrighty, well, hello everyone. Bonjour tout le monde. Welcome, bienvenue. Welcome to the NSERC Collaborative Research and Training Experience Program on the theme of science leadership for global sustainability in the digital age, or LEADS. We are so pleased that you could join us on Zoom, hi everybody, or in person here in Fourth Space. Just to situate you, we are streaming on YouTube Live from Concordia University's Fourth Space, which is located on unceded indigenous lands in Tiohtià:ke, Montreal. And as caretakers for the lands and waters we are meeting on, we are grateful to the Kanien'kehá:ka Nation for their teachings about the earth and our relations. For those of you who are with us for the first time here in Fourth Space, welcome in. You may, you're welcome in every day because in fact, every day we collaborate with our university community for different types of events to activate the various projects that are ongoing at the university, dialogues and research projects in development. And today we have the pleasure of hosting this LEADS session. We are running this event as a live stream Zoom. So those of you on Zoom, there might be time for questions and comments. So feel free to turn on your camera, raise a virtual hand, or pop something into the chat, and we'll see it here in the space. And those of you who are in the space with us, well, once again, we're so happy that you're here. Feel free to adjust your chair to your will. So you'll see the big screen kind of behind you. We've placed another one, a smaller one in front of you. Don't feel like you have to crank your necks. Please make yourself comfortable in the space to see what you need to see and hear who you need to hear. And if you do have a question or comment, just raise a hand and we'll get one of these handheld mics to you so that people on Zoom can hear you. That's it for me. Over to your host for today, Damon Matthews. Hi, Damon.
Hi, everyone. Thanks for coming. Is the mic on? Can you hear me? I won't do that again. Okay. Welcome, everybody. Nice to see people in person. Welcome to those of you on Zoom as well. So I'm just going to do a quick little opening 5-minute or so intro, and then I will turn it over to all of the students and collaborators who are here who are going to do short presentations. We'll either take questions after each one or in clusters, depending on how the timing goes. So I think everyone has a sense of what we are and why we're here. But we're now entering the third year of the LEADS program. We have something like 40 students who have come through the program so far. And so the presenters today will be mostly from the cohort of students who started last September in the second year, or so now have been in the program for about a year. And then welcome also to any of the new students who I haven't met. I'm glad you could join us. So this idea for a program, a graduate training program related to digital innovation and sustainability science emerged from early conversations with Amy Lewers, who is the executive director of Future Earth some number of years ago. And this idea that there are, two major forces that are shaping the world today. One is climate and environmental change, which is, moving very rapidly. The other is digitalization and digital innovation and AI and machine learning, which is, a tremendously powerful force that is changing how we do things, around the world. And it really makes sense to try to have these two things working in parallel to move towards a better world, and in particular to be able to leverage the tremendous learning and innovation that's available in the digital space towards trying to solve some of our pressing sustainability challenges. So that was the idea of this program, and the premise is to provide training that will develop skills and knowledge and experience in sustainability science, but also in this digital innovation space, to be able to use those tools and techniques and abilities to mobilize a more sustainable and equitable global society. There's a number of different aspects of research going on in the program. These were the initial 3 themes that we conceptualized when we began the program. I would say that they don't adequately represent the program anymore. Students are doing a wide variety of research, anything from ecology to fine arts, and so there's really a large catchment of research projects, and we'll hear some details about that today. But the fundamental cohesive theme is how can we move forward toward a better, more sustainable world, and how can we accelerate that transition using the best available tools that are out there. The actual components of the training program that anyone who started last year has experienced. We do offer internships either with Future Earth, and we're going to have Santiago speak in a few minutes to talk about some of the work going on at Future Earth and sustainability in the digital age, which is now set up as a Concordia think tank. So there's internship opportunities through the program. We run a summer school each year, which we've done twice now. We are promoting what's called collective leaderships. This is the idea of how do we build, or how do we develop into leaders who can speak across different disciplines, speak across different stakeholders, work with diverse teams of people to enact positive change in the world. And so this is a really important feature of the program. In the digital space is this idea of collective intelligence also. How do we use digital tools to mobilize intelligence from around the world in a way that we couldn't do in the absence of the tools that are now available? And then we have a periodic seminar and workshop series that will be advertised as we go through. And this year also, for the first year, we have a student committee who is active in organizing many of those workshops. And so I look forward to seeing what comes of that this year. Finally, there's various opportunities to attend science policy meetings. Of course, the COP15 meeting is happening in December this year, but Future Earth and also Concordia and many of the universities have access to some of these meetings. And so I would encourage students who are interested to look into that for future meetings. This is the leadership team, I would say, of the grant, although the actual involvement extends far beyond this. So I'm not going to dwell on this, but this is the group of researchers who are formerly the principal applicants on this program. We represent the 4 Montreal universities, and then we have collaborators also at other universities within Quebec. So I'm going to show this little video clip quickly, and then we'll move on to some presentations. This is some collections from our first year, which of course we launched entirely on Zoom, which was apropos given the theme of the program, but nevertheless an interesting experience.
C'est ce que j'aime de ce projet-là. On parle de leader quand même, de meneur, quelqu'un qui sera un chef de file, capable d'amener les gens, mais de comprendre que pour ça, il faut aussi être capable de s'appuyer sur les données, appuyer sur les études, parce que on le voit par exemple avec la COVID, les problèmes auxquels on fait face aujourd'hui, ce sont des problèmes ou des enjeux scientifiques. Il faut comprendre les enjeux scientifiques pour passer au niveau social, puis au niveau des valeurs, puis au niveau des transformations.
I think that what's really interesting about the digital innovation part is that digital innovation can be a barrier and an enabler, because it can be democratizing or it can be something that's part of an elite. And so it's going to be really interesting what type of innovations are we talking about and what type of tensions and struggles are ongoing and occurring. And that's really interesting.
One questions that usually arise is how real does this scientific findings contribute to policy initiatives and in aiding sustainability, and how can we also use research findings to build digital innovation tools for sustainability?
This program is going to provide students with a lot of really great opportunities to learn skills that they can take out of academia into future jobs, or into future jobs within academia as well, so that we're not so much in the ivory tower.
I don't just want to point at a problem and identify potential solutions, but I actually want to work to see those solutions be implemented as actual change.
Moi, ce qui me motive énormément, c'est, je pense qu'ensemble, on risque d'être très très fort, dans le sens où je pense que les gens qui sont autour de la table, c'est une équipe absolument fantastique, et je pense que c'est ce qu'il faut pour arriver vraiment à un vrai changement.
The initial vision that was sort of the seedling of this was that to really drive the types of transformations that we're seeing, that we believe we need in the world, and to manage the full range of risks and opportunities, that we build a group of leaders that have the bilingual into the language and the skills of the natural and the digital world.
I think it's a really important tool, and I think there's a lot of potential to leverage digital technology, digital innovation, and the strategies involved in those, and the skills that the people working in those areas have towards mobilizing solutions around climate change.
Okay, so I think we'll move straight on to the presentations. This is really about how do we achieve sustainability in this digital age. So I'm going to start with Santiago, and I'll invite you to come up. And Santiago's going to speak a little bit about some of the work going on with our partner organization, Future Earth, and sustainability in the digital age.
No need, it's fine. Hey Ryan, what's up? So hi everyone, I'm Santiago. I'm a project manager for Future Earth and Sustainability in the Digital Age. And as my shirt says, I'm also an explorer for National Geographic. And I'm going to tell you a little bit about what we do, and then you can ask Ryan or Katia for like the details, because I've already worked with both of them. And you sort of know me a little bit too, Aaron. But so I'm going to tell you first about the projects we're working on right now. That's what we're doing right now, and the projects we have in the oven. And hopefully I'll get your attention, and maybe some of you might end up working with us, maybe, because you can intern with sustainability in the digital age, and we always need a few helping hands. So one of the projects we're working on, it's around the interface of nature-based solutions and digital innovation. So we have already done previous research with Katia and Ryan, exploring what's the landscape of nature-based solutions in Canada. And well, we have found out several things, but I think one of the most important things is that we have found that all of the part related with monitoring, reporting, and verification of the effects, of the beneficial effects of nature-based solutions is all over the place. You can you could focus in biodiversity, you could focus in effects in carbon, effects in clean water, social effects of nature-based solutions, but only focusing in carbon, you can you'll find out that everybody reports carbon emissions in their own specific way, and the same works with carbon uptake. So it's a little bit all over the place, and we're trying to see how we can unify those different monitoring, reporting, and verification schemes. So one of the things we're working on three main things at the moment. One of them is we're working with Microsoft. So Damon mentioned Amy Lewis, and we're working with them and their planetary AI computer team. And we're trying to see, well, based on all of the data they already have, all of the environmental and biological data they have of different parts of the world, so we're basically trying to see how we can use that to maybe close that gap, that monitoring gap I mentioned. So we're trying to explore, like, if we have all of the data we need to the scales we need, if we have, potentially we have more carbon and biodiversity data than we have social data, which should be an integral part, I think, to monitor as well in this project. So we're definitely looking for people that have a kick for GIS or machine learning methods so that they can explore this with us, because we also like to use a lot of satellite imagery to measure all of these variables we need, and we don't necessarily always have the images at the resolution we need or at the temporal or spatial scale we need. The other thing we're doing is that we also found out that there are several nature-based solution projects in Canada, but not all of them report in the same way, not all of them report at all. So we're hoping to create one of the first, I think the first nature-based solution database within Canada. And we're hoping we actually started working with the University of Oxford on that database, because they already have a database, but for international initiatives. So if you also want to learn a little bit about the landscape of these projects in Canada and in the planet, that's also something that we would need help with. And the other really cool project is that we're working with the Conservation Through Reconciliation Partnership. So it's an Indigenous organization in Canada that's focused on Indigenous conservation. And we have been exploring all of the different intricacies that can lead to Indigenous carbon rights. So we meet with an Indigenous circle of leadership every week, and we talk about what are the steps we need to get to integral nature-based solutions. A part of it is the monitoring, as I mentioned, but other parts that need to be aligned include like working together with Indigenous peoples and them leading these projects and us grounding all of these projects within Indigenous knowledge. So if you're also interested in that overlap of conservation, technology, and Indigenous rights and stewardship, you're also more than welcome to talk with me or Andrea or Katia later, and we can talk a little bit more about that. And very fast, the projects we have in the oven, that means that we still haven't secured funding for that, but maybe, and if that helps like to get your attention even more, that works better. So one of the other projects we're working is with Sargassum Seaweed in the Caribbean. That's also part of what I do for National Geographic, and I'm trying to bring it to sustainability in the digital age. But basically, I don't know if you are familiar with Sargassum Seaweed, but it's a seaweed that in the past 7 years has been increasing a lot in the Caribbean. So every year during summer, millions of tons of this seaweed get to the Caribbean, to all of those places that you would like to visit, like the whole Riviera Maya in Mexico, Cancun, Tulum, Miami, Puerto Rico, the Turks and Caicos, Barbados, Bahamas, the Dominican Republic. So all of those pretty places are getting swarmed by this seaweed. So we're developing different projects to train people to transform that seaweed into products of economic importance, like clothing, fertilizer, bioplastics, biogas. And we're also trying to develop, we're starting to work with a few researchers that work in the Google Earth engine, because again, the part with the satellite imagery and the data, we don't have information at the spatial and temporal scales we need to inform people about the path of this seaweed. So that's the other thing we're working on, like tropical seaweed stuff. And the other really cool project, it's in the north of Canada, and hopefully we get it. We're gonna be working with 3 different Indigenous protected areas in the Northwestern Territories. And this project is being led by Steven Nita, and he makes part of the Lutzelk'Dene First Nations a few kilometers away from Yellowknife. And what we're trying to do is, again, this overlap of nature, Indigenous leadership, and technology. And we're trying to create the first platform that sells irrecoverable carbon credits, it would be the first platform that it's first Indigenous led and the first that sells irrecoverable carbon credits. But I think I'm super, I think this is over 5 minutes now. So if you want to learn about any of these projects, well, just come and talk to me later. I'm happy to meet you all. Thank you.
Thank you, Santi. So if anyone is still looking for internship opportunities with Future Earth or sustainability in the digital age, do be sure to talk to us. Maybe Andrea and Nilu can also just stand up and wave as the others who are involved in many of these projects at Future Earth and SDA. So we're going to move on to our first student presenter. Talo, if you want to come up to the mic, I'll get your presentation set up here, and then you should be able to advance the screen momentarily using the clicker there if you would like.
Bonjour à tous et à toutes. Je suis très content d'être ici parmi vous. Et je suis Talo Bertrand, étudiant en 2e année en sciences de l'environnement. Et je suis en train de travailler sous la supervision de ma directrice de mémoire, Cécile Bulle. Et je voudrais vous présenter un résumé de mon travail de recherche qui se porte sur des données de cycle de vie plus robustes pour mieux documenter les décisions des consommateurs québécois en matière d'alimentation. En effet, en termes d'état de la question, et face à l'urgence climatique et aux défis des connaissances, et dans le cadre et en considérant le mouvement de mobilisation citoyenne au niveau du Québec, eh bien, on a décidé de mettre en lumière, de travailler pour mettre en lumière des données au profit des consommateurs et des consommatrices au niveau du Québec. Et c'est dans le cadre du projet et boussole durable, en lien avec le CIREG qui a pris qui a fait une modification dans son nom pour le moment. CIREG, c'est le Centre international de référence sur l'analyse du cycle de vie et de la transition durable. Et compte tenu des efforts en cours à l'échelle mondiale, notamment en France, la Suisse par exemple, et on est en train de travailler sur l'analyse du cycle de vie pour les consommateurs et dans différents axes d'intervention. Ici, au Québec, il y a une absence ou bien un manque de données en matière d'alimentation. Et comme on est en train de faire des efforts à l'échelle mondiale, et il y a le CIREG qui a travaillé sur une base de données 0, qu'on appelle version 0, et cette base de données-là contient 372 de jeux de données, comme vous pouvez le remarquer, et à gauche dans le schéma. Et avec cette base de données-là, il y a un manque, et surtout en matière et sur le plan agricole, et par rapport, si on considère par exemple le cas de la viande de bœuf sur laquelle je suis en train de travailler. Là encore, on se donne pour objectif de combler cette lacune qui existe au niveau de cette base de données, et avec mon travail, on aura la possibilité de mieux travailler sur l'analyse du cycle de vie, sur le volet alimentaire, en particulier sur la viande de bœuf. Et dans ce cas, ce sera vraiment une sorte de référence ou bien une innovation pour le Québec, parce que les citoyens auront accès à certaines informations, à des données, et ça pourrait contribuer à des travaux de recherche, et non seulement à l'UQAM, à l'Université du Québec à Montréal, et dans toutes les autres universités au niveau du Québec, ce qui sera vraiment important en ce qui concerne la recherche dans le contexte local et dans le contexte international. Je crois qu'avec ce travail de recherche, bien, on aura la possibilité également pour mettre à profit à chaque citoyen et à chaque citoyenne de mieux comprendre par rapport à la mouvance qui existe à l'échelle mondiale pour lutter contre les changements climatiques. Car, quelle que soit l'origine de l'effet ou bien d'un gaz à effet de serre, eh bien, la conséquence, il y a automatiquement des conséquences sur les changements climatiques. C'est pourquoi, eh bien, ce travail-là sera vraiment une référence non seulement pour l'UQAM, mais pour tous les autres partenaires qui travaillent en lien avec nous et au niveau du CIREG et avec les partenaires du projet LIEN-D auquel je suis en train de travailler comme bénéficiaire et comme boursier. Et je crois que ce sera vraiment important pour vous de suivre les résultats de ce travail. Sous peu, d'ici décembre, je compte terminer avec ce processus de travail. Et nous sommes en train de faire ce qu'on appelle la collecte et le traitement des données pour pouvoir compléter cette lacune-là ou bien résoudre ce problème de manque de données au niveau de la base de données sur l'axe alimentaire. Merci de votre attention.
Merci Talo. Donc je pense que ce qu'on va faire, on va faire le demi des présentations, puis on va prendre une petite pause pour les questions et on continue à cette façon. Donc la prochaine, next presentation is one of our new collaborators in the program, Renata, who is on Zoom. So if you give me a minute, I will load up your presentation. Okay, whenever you're ready.
Hello?
Yes, we can hear you.
Hi, Damon. Can I start?
Yes, please.
Go ahead.
Okay. Hello, bonjour. My name is Renata Ferreira, and thank you very much for inviting me here. I'm very proud to join this meeting. It's already starting really interesting. So I am a professor at, I thought I would share my screen. Can I share my screen? Can I try it so I can
If you'd
move
rather.
yeah, let me just, can I share it? Maybe just, can you see it? No.
Yeah, good.
Can you see it, Damon?
Yes.
Okay, so thank you. So bonjour, I'm Renata Ferreira. I'm professor at the Federal University of Rio Grande do Norte. I'm very proud to join this meeting. And in this 3 to 5 minutes talk, I'd like to present the research conducted in our lab, Collab, Studies on Coexistence. So the main theoretical question of our lab is which factors contribute to group coordination. And we do this by researching variables from individual level, such as personality, to different ecological variables. All the research in our lab aims to have practical answers to the question how to manage animals in human disturbed environments. And we do this by focusing on animals in rescue center and in one Atlantic forest fragment. The research of our conducted in our lab can be used many different species, such as visual attention and coordination in marmosets, voting and collective decision in horses, and as I live by the sea, why not to study fission fusion in dolphins? We also conduct the study focusing on humans, such as strategies for managing aquatic reserves. And more recently, a PhD student conducted a study on prosociality and social network in kindergarten children. But the main focus of our research have capuchin monkeys as a model. So here is the example that I will not present a lot because Jack Cragen and Kyle Miller has just finished their research, their data collection. So I'll let this for Jack to explain his research. This is a collaboration with Sarah Turner. Yeah, thank you, Sarah, super nice. Meanwhile, and this is an example of the research we can do, linking practical and theoretical questions. So this is a paper has just been published, Factors Influencing Terrestriality in Primates. Here is our research area where Jack has been. And in this, we discuss the importance of climate change, diminishing forest coverage and proximity to cities as a evolutionary pressure to terrestriality. One main research question is the reintroduction of rescued animals. Here we have two new students, Jennifer, that is helping us in collaboration with Angela to define release areas, and Michaela, that is going to come here hopefully in May to conduct the post-release monitoring of animals and hopefully conduct some survivorship analysis and movement analysis. So hopefully this girl will bring better and different pictures for the next meeting. We are also starting some partnership with epidemiology to conduct monitoring of diseases in these rescued animals. We keep an Instagram for scientific education and problematization. And I thank Sarah for the partnership, and you are all welcome to conduct research in any of these species, in any of these areas. Thank you very much. Merci.
Next up is Jack, who is also on Zoom, and I will there we go. So go ahead whenever you're ready.
You can hear me, right?
Yes, good.
Okay, cool. Hi, my name is Jack Cregan. I'm a master's student in Dr. Sarah Turner's lab, being supervised by both Dr. Turner and Dr. Renata Ferreira, who you just heard speak. And I spent this last summer, as Renata said, in the northeastern part of Brazil, conducting my research on blonde capuchins, which you can see at the top of my slide there. Now, like many primates, blonde capuchins are endangered. They live mostly in the Atlantic forests of northeastern Brazil, where much of their former habitat has been replaced by agriculture, mostly sugarcane. And what habitat they have left has been reduced to what are called forest fragments, an example of which you can see in the top right of my slide outlined in red. Now, this particular forest fragment that you can see is the one I conducted my research at. It's about 290 acres of very hilly forest, which partially explains why it hasn't been cut down for farming yet, and is home to two large groups of blonde capuchins, with each group living on either side of the horseshoe shape that you can kind of see there. Now, the group that I studied inhabits the east leg of the fragment, or the east side of the horseshoe, and was made up of around 150 individuals, which is, as you might be able to tell, is a lot of individuals for such a small area. And because of this, there aren't a lot of available resources for these capuchins, so they've come up with some interesting strategies to survive in this kind of situation. One of these, for example, is that they've begun raiding and consuming the sugarcane crops that surround their fragment, so much so that in some months it makes up as much as 70% of their diet. Sugarcane consumption also causes an increased amount of competition within the group, as some individuals choose to steal from other individuals rather than taking the risk of getting their own. Although I should say these kinds of conflicts are still relatively uncommon and rarely escalate beyond verbal confrontations. Capuchins are pretty peaceful compared to a lot of other primates, and in some sense, they're kind of forced to be. These blonde capuchins are essentially stuck in their fragment, as there isn't enough safe habitat for them to emigrate to, so they do end up having to be pretty diplomatic about things. Now, while there has been a lot of research done on capuchin behavior in the past, very little of it has been done on capuchins living in forest fragments. My research examines the strategies they've come up with that allow them to survive in crowded situations like this one by monitoring their location in the fragment, how far apart they are from one another, and which individuals are where. I use scan sampling to gather GPS data on each individual using an app called Locus Map, which you can see on the bottom right of my slide. Now, each one of those dots you can see is a data point, and with each one of those points, I also recorded the approximate age, sex, behavior, and height in the canopy of each capuchin. Now, collecting this data allows me to test if certain coping strategies are occurring, such as niche differentiation, which is where individuals of the same species, and in this case, the same group, fulfill different niches in order to reduce the amount of competition between each other. With age, sex, behavior, and height data, I can see if adult males, for example, are foraging significantly more on the ground than females or juveniles. And if they are, then this can indicate that niche differentiation is one of the strategies allowing them to survive with limited resources. And by better understanding the strategies blonde capuchins may use, like niche differentiation or others, I can better understand how they use their space in the fragment. This will help inform the creation of protected areas for blonde capuchins and other primates so that we can hopefully prevent the extinction of these interesting and unique little animals. Thank you.
Great, thank you, Jack. So next up is Graham.
Hi, everyone. Okay, my name is Graham. I'm a master's student with Damon. My research is focused on constraining climate models with observed climate. Oh, thanks. Sorry. Much better. So ideally, climate models would create perfect representations of reality, but simulating the climate is a complicated process, and not all climatic processes are fully understood and can be properly represented in a climate model. For this and several other reasons, climate models can deviate from observed climates. For my own research, I will look at a forest carbon representation of a climate model, a small piece of a component of a larger model. This component often represents many different processes. I've included a picture of all of the processes included in a large climate model. You can see there's a lot of different things on micro scale or macro scale, say root litter or changes in forest dynamics. I'll use AI to learn these relationships between forest carbon and several climatic drivers, such as temperature, topography, precipitation, solar radiation, factors that inform carbon flux. Once these relationships are codified, I'll be able to apply them to generate forest carbon stocks that are driven by observed climate data. The model I will make will be a simplification of the picture I've included. Instead of attempting to learn all of the relationships shown, I will only look at the drivers that contribute to the majority of variation in forest carbon stocks. Another way to think about this project is that I'm making an emulation of a small component of a climate model. I'm making a model of a model, and I can use this emulation to quickly generate estimations of forest carbon stock. These emulations can be informed by a bunch of different data sets, future projections, or different observed climate data sets. Canada uses climate models to report their greenhouse gas inventory for forest carbon stocks. And I'd like to use this research to be able to compare several different climate models to their output. Thank you.
Great, thank you, Graham. Moving on to Aaron. If you are there, I will.
Oh yeah, it's a little tall. Thanks. Yeah, great. So hi everyone, my name is Erin and I'm part of the Land and Food Lab at McGill University under the supervision of Dr. Graham McDonald. And so this is just a little overview of my research so far. And my current working title is Untangling the Role of Crop Diversity in Agriculture Landscape Structure, Global and Regional Perspectives. So this is a global map of crop diversity that we created using global crop maps, SPAM and Monfreda, and following the methodology of Merlot and Hyman's 2020. So the color gradients you see here show different global patterns of crop diversity. And so as you can see, there are some regions with high crop diversity, like in China, Europe, and Western South America, and also others with lower diversity, such as in the United States, Canada, and parts of Russia. Oops. And then just to say, or just a note, crop diversity and agrobiodiversity in general are important for the provision of ecosystem services, and diverse agricultural landscapes may be more resilient to disturbance and environmental change. So there is a growing interest to increase crop diversity wherever possible. So agricultural landscapes are commonly assessed in terms of heterogeneity, which can be defined as the diversity of land cover types or the composition and their spatial arrangement or configuration. So in my research, I will be using the Shannon Diversity Index, which represents the effective number of crop species as a measure of agricultural landscape composition, and then cropland field size as an indicator for configuration. So as a preliminary analysis, we examined the relationship between composition and configuration with these independent global spatial data sets. And we hypothesized that crop diversity would track patterns of field size with a general negative relationship, i.e. high crop diversity would coincide with smaller field sizes. And as you can see in this figure, the nature of the relationship between landscape composition, crop diversity, and configuration or field size varies considerably across, or varies considerably like globally. So you can see here that in Asia, Africa, and Europe, they share similar crop diversity distributions, but with very different dominant field sizes. Africa and Asia, for example, have very small fields and relatively high diversity, whereas Europe has relatively high diversity on large and medium fields. And then North America is made up of mostly large and medium fields, but with lower crop diversity. So we also conducted a similar analysis for the United States due to the availability of a really detailed data set that included like every field segment in the US, which is very cool. And so again, we see some variation in the relationship between landscape composition and configuration just across the US. So again, the negative relationship between diversity and field size, you can see that in Iowa and Kansas on the right there, and that this generally conforms to our initial hypothesis. However, we also saw in some states, such as Montana and Kentucky, that high crop diversity coincided with smaller field size. And just moving on for the remainder of my thesis, I would like to investigate this relationship between crop diversity and field size on both regional and global scales, and then try to, again, visualize this relationship. And I would also like to consider if the relationship between crop diversity and field size is influenced by more general landscape diversity, so like semi-natural land covers, like forests. Great, that's it.
Okay, actually, I'd like to take a few minutes for questions at this point. So we've had 5 presentations from Talo, Renata, Jack, Graham, and Aaron. Would anyone like to put out a question for any of these presenters before we move on? So you might need a microphone in order to be heard by the Zoom audience, I believe. And presenters also, you'll have to either get the microphone or come back up to the front to answer your question.
Was it Jack or Graham that talked about monkeys in fragments?
Jack. So Jack is on Zoom.
Okay.
So I think Jack,
the little question that came into my mind is sugarcane a healthy diet for monkeys?
No, so it fulfills their caloric requirements, but because it's so sugary, it lacks a lot of the nutrients that they would normally get from eating fruit, which is usually their preferred food. So yeah, no, not healthy for them at all.
Alex.
This is a question for Aaron. For the crop diversity, at least in the US, is it limited at all? Like, what is the cause of the difference, the huge difference in crop diversity? Is part of it like the culture of the farmers or the corporations that are growing, or is there limitations, like major limitations too, of the climate or geography of the areas?
Hello? No, so that's a good question. And I think when you look within the US, you also see, especially in the western part of the US, they're mostly growing corn and soy, so there's less diversity. I think there are a lot of factors that go into this. I will be focusing mostly on landscape structure in my research. So you could say that because in the western part of the US, you have mostly these large fields growing one crop, whereas in a state like the East or in like Tennessee, you have examples of like smaller fields and where they're growing multiple different crops. But I think there are also other underlying factors like land, like the history of the land, or what's even possible to grow there. So yeah, I don't know if I answered with your question, but I guess there are a lot of like factors that go into it.
This is for the, I don't remember the name of the presenter from Future Earth that did at the beginning.
Santiago,
yeah. So about the Sargassum seaweed, I was wondering if there's been research looking at the cause of the increase over the last, I don't know, you said few years. So I was wondering if the causes, if that's known.
Hello? Yeah. Yeah, actually, there are at least 2 confirmed reasons why. And then there's like several hypotheses. One of them, of course, is climate change. But climate change because of 2 reasons. First, increases in water temperature, so that speeds up the reproductive process of the seaweed. But another really cool one is that normally, I don't know if you know this, but between Europe and the Americas in the middle of the Atlantic, there is this massive patch of seaweed called the Sargassum Sea. So even Christopher Columbus, he passed through there and he wrote that in one of his journals. So it's been there, you know, for over 500 years. But with the changes in water temperatures, that has also affected the normal path of the sea and ocean currents. So the water on the surface starts to heat up, and then, well, the water moves in different ways because you know how cold and water warm and cold particles move differently. And these changes in currents are now taking sargassum from the Sargasso Sea to places where it normally wasn't going, apart from it reproducing even faster now. The other part is that, well, we really like our fertilizers when we do crop-related stuff. So all of that, so it rains, right? Then all of those nutrients go into the rivers and eventually to the sea. So you have higher temperatures and very nutrient-rich waters, which sargassum loves again. And so that's why we're getting these massive amounts of sargassum. And it actually makes a really crazy path. It goes up from northwestern Brazil. It goes up through the Guyanas, Suriname, Venezuela, Colombia, then it goes to Mexico, Miami, all of the Caribbean islands. And it even goes back again to Eastern Africa, goes through Guinea, Sierra Leone. So it affects so many countries. And I was just in a meeting with some people in Mexico. So Mexico gets massive amounts of sargassum, and they're blaming all of the agriculture in Brazil. But I think at the end of the day, everybody's contributing a little bit to the problem, whether if it's through carbon emissions and the increasing water temperature, or everybody with our fertilizers and everything we're releasing into the ocean. So yeah.
Thank you.
Okay, great. Why don't we move on with the next group of presentations? I think next up is Sarah. So Sarah is not a new collaborator, but a newly entrained collaborator who will be working with a student in the program this year.
Laetitia, who's over here, who's just starting the program. So I'm at the University of Montreal. Je travaille au département de sociologie à l'Université de Montréal, but I think I'll do my presentation in English. I've been studying, I'd say for about 20 years, I've been studying the relationship between forests and communities, mostly in Canada and a little bit in Scandinavia. And initially I was interested in kind of local-based models of community-based management in Canada and beyond, to sort of understand whether there really was an alternative to the industrial approach to forest management in a country such as Canada, which has such a strong history of large-scale and industrialized forest management. And since I've been working in the sociology department, I've been mostly working on forms of engagement within forest management and forestry governance, with a lot of attention to Indigenous rights. And so I'm interested in citizen engagement, and I'm interested in different types of mechanisms for co-management, public participation, and that type of stuff. And I've actually focused quite a bit on, and I'd say that the main research project that I'm working on right now has to do with forestry certification. So some of you have probably heard of Forest Stewardship Council, which is really heralded as a way for corporations to improve their sustainability practices, and it speaks to economic, ecological, and social dimensions of sustainability. And there's a big piece of FSC which is also focused on Indigenous rights and the idea that companies are going to be able to enhance their relationships with Indigenous peoples by adhering to this FSC certification system. So the project that I'm working on right now is international, and it was initially including Sweden, Canada, and Russia, but we're no longer doing the Russian piece of that project because we won't be able to do any field work in Russia. And FSC has actually kind of halted all their operation, or all their certifications in Russia since the Ukraine conflict. And so what this project is looking at is really the requirements that FSC has introduced in the last few years around free, prior, and informed consent. So I don't know if many of you are familiar with that, but that's really considered to be sort of at the cutting edge of engagement with Indigenous peoples from a governmental perspective, and also from a corporate perspective when you speak to these kinds of initiatives like FSC. And FPIC, as it's often referred to, is in the United Nations Declaration on the Rights of Indigenous Peoples, and it really is meant to be kind of an instrument to advance Indigenous self-determination and basically a type of co-management or Indigenous decision-making authority within extractivist contexts such as forestry. So I'm very interested in how this is evolving within FSC, because it is one of the only certification initiatives that has really endorsed FPIC as its main instrument for ensuring the protection of Indigenous rights. And so first we did a first chapter of this research project was really looking at how the FSC standard is developed, because it's a very interesting example of kind of like democracy in action, where loads of people can become members of FSC, industry, NGOs, Indigenous organizations, and they all need to negotiate the standard together. And so it's really like an experimental way of trying to operationalize the notion of FPIC, because they need to come down to the indicator level and try to figure out how to operationalize this on the ground. So we did a first stage, which was really looking at the standard development processes and how they differed between Russia, Sweden, and Canada. And also there's an underlying kind of, I guess you could almost say like a theoretical framework within this project, which is really to understand to what degree it's being interpreted in a substantive way, which is the way that I just described it as being kind of an instrument towards self-determination, versus what you can call kind of a more procedural or I don't know, you could probably, there's other terms that are used to explain it, but basically the notion that it's something that can help companies and governments in the pursuit of free, prior, and informed consent, but that the actual outcome of FPIC is maybe somewhere down the line, and it's really like another instrument towards better practices, but not necessarily to the extent that one would aspire to in the vision of human rights organizations and Indigenous organizations and so on. So that there's sort of a spectrum in some ways when you think about FPIC, and some corporations are probably on the lower end, and others, governments, are striving to move more towards a more substantive interpretation of FPIC. So now we're moving into the second phase of this project, which is really about implementation. So I'm doing a type of survey of all the companies in Canada that have already been assessed under the FSC standard to really understand what practices look like on the ground with regards to FPIC and implementation. And then probably later on, we'll be doing some case studies to kind of get into the nitty-gritty of things. So that's my main thing that I'm working on. And then I also, just to mention really quickly, I'm starting to work a little bit more in the area of citizen science and citizen engagement within kind of in a totally different field and within an urban environment. And I'm working with a professor in the chemistry department at University of Montreal who's involved in kind of small scale monitoring of air quality in Quebec City, where air quality is quite contentious, and using sort of small scale remote little sensors to measure air quality, and is very interested in bringing a social social science research perspective to that in order to understand better how to engage with local citizens, and also what's the potential for kind of awareness and education through citizen science. So that's me. Thank you.
Great, thank you, Sarah. Glad to have you participating this year. So moving on to Fatima. I'll get your presentation loaded up here.
Hi everyone, my name is Fatima. I'm a PhD student in Geography, Urban and Environmental Studies at Concordia University. My supervisor is Dr. Joignez-vous, and my co-supervisor is Dr. Matthew Perez at Bishop's University. My PhD is on paleoflood reconstruction of Ottawa River Basin using sediment cores. The problem that my PhD project is centered on is the fact that we don't have enough instrumental data on floods on the Ottawa River Basin. Filling this gap, we want to use a paleoflood reconstruction. As you can see in my slide, the basin is heavily dammed. The picture, like bottom left. So we don't have enough uncontaminated data, and only like the green ones are the natural gauging stations that we can use, and we have the informations that can help us. But they are really sparse, and at the best, they begin at early as 1910. So we don't have a long-term record of the floods in the basin. So in my project, we are going to use paleo-flood reconstruction. The problem is that we had severe floods in the Ottawa River Basin in 2019 and 2017. And it wasn't the first time, because we had them also in 1974 and 1976. You can see a picture of the floods of 2019. The floods of 2019 and 2017 resulted to evacuation of more than 14,000 people and more than 1 billion governmental damage. So what we are going to do, we are going to take sediment cores from Oxbow Lakes, those C-shaped lakes next to river that you can see in my slide and top right. We use Oxbow Lakes because during the floods, Oxbow Lakes connect to main river channel, and they can act as a sediment trap. And the sediments that we have in Oxbow Lakes are different from the normal sediments that usually we have. So the sediments that the floods brings is different in composition. We take them and we radiometrically date them, and we can use we can track the past sediment change and infer past flood change. As you can see in the last slide, we are going to, last picture, we are going to use a vibrocorer, and hopefully my project will provide watershed managers with better long-term flood data on the basin. Thank you.
Great, thanks so much, Fatima. Next on my list is Caroline.
All right, hi everyone, my name is Carolyn, and I'm a master's student in the Primatology and Interdisciplinary Environmental Studies Lab here at Concordia, and I'm studying habitat suitability, space use, and human-wildlife coexistence in wild river otters on Protection Island, British Columbia, under the supervision of Dr. Sarah Turner. So global change and urban sprawl increase the likelihood of encounters between humans and wildlife. And my study species, river otters, is a species that's known to both coexist but also conflict with humans over the use of space. And so my study site, Protection Island, on the bottom left, is a suburb of the city of Nanaimo, has a relatively high density of humans, and is in close proximity to Seisitchin, or Newcastle Island Marine Provincial Park, where humans are only day visitors. And so Protection Island is an interesting and ecologically relevant site to study habitat suitability and human-wildlife coexistence in a relatively urban environment. So I spent this past summer on the island characterizing the habitat using a GPS, conducting surveys, and using trail cameras, like on the bottom left, to determine where otters are and are not using space in this environment. And so I plan to use the habitat characteristics I identified, other spatial factors that I've gotten from various databases, and sightings and other signs of otter presence to model habitat suitability and space use in this anthropogenic landscape. And I want to find out what factors might predict otter habitat use and what trade-offs they might make when they share habitat with humans. Otters are seen as a nuisance by many residents of the island, primarily because they den under people's homes, they defecate on docks and in people's boats. And so this has led residents to find creative methods to keep them out of their homes and out of their boats, including using spikes and sonic emitters. And so because of this, I also conducted interviews and surveys with residents of the island to understand their perceptions of and attitudes towards the otters. And I hope to examine the themes from these interviews and contextualize them within the critical animal geographies and conservation management literatures. I've yet to do any analysis, but it's been interesting to see that while some people have negative feelings towards otters, they still feel that it's important to coexist However, others have also found dead or dying otters that they suspect have been poisoned by a specific resident of the island. So I look forward to getting a clear understanding of the differences in attitude and perception among the residents and what may be the underlying causes of these differences. And I hope this will have implications for conservation initiatives, because if we can identify habitat characteristics that are important for otters in anthropogenic environments and increase our understanding of the human-otter dynamics in this landscape, then we can promote human-wildlife coexistence and ensure the presence of suitable environments for this species, particularly in areas with anthropogenic pressures. Thank you.
Thank you, Caroline. So good, moving along. Next up is Lila, one of our collaborators, and Jorge also will be joining her. So just give me a moment and I will get your screen, your presentation up.
Can I start even though the
Yes,
slides are there?
please.
I wanted to give you a snapshot of the art projects emerging from the old growth forests that started in 2016 through to the present, along with the conversations that built an interdisciplinary network, elastic 3D spaces. So presenting with me is Jorge Zabagno, who started as the technical director with his expertise in IMAX technologies. And along the way, he decided to do a MA Indie project and is just completing that this December. So the first slide you saw was a wiggle GIF that allows you to experience these old growth forests. Over to you.
Yeah. So this is the field work that we did. There was a film shoot in June 2016 in Vancouver Island near the Walbrand Forest. We took two F-65 cameras to be able to film them in a 3D rig. That means we were filming stereoscopic, which is how you got the wiggle GIF. And then in August 2018, we did a project, an IMAX project, that we filmed with a heavy lift drone and a red weapon camera that shoots in 8K. And we'll show some of that. But
I was just telling Sarah, she's in the next slide. So as we started the showing of the footage, we met various people, and those conversations built into the interdisciplinary network that we're working with now. So I was in Dr. Suzanne Simard's field site in British Columbia, and that conversation has begun a long collaboration, likewise with Sarah Turner and Damon Matthews. And it's exciting, and Nancy Turner as well. Her book, People and Plant Places, is the one pictured here. Another wiggle GIF for you. And one of the things that Sarah said to us that really captured us was that it was the project we were working on when we show it in the 50-foot space we have in the black box in the EV building, was the closest to an old growth forest that is not an old growth forest. So it was an example of the digital, and this is a wiggle GIF so that it can be circulated. We can give you each a GIF. Along with the trees themselves are the indigenous relations. And so one of the things we noticed was that a lot of people come in from France, Germany, all over the US, Canada, to film these forests, but nobody ever gets to see it, who lives there. So we started a process of screening. We screened the rushes. We asked for permission to shoot. We took the edit back to the nation. And what we don't have time to show you today, but it became the site of the largest citizen protest And it echoed the protest 30 years ago that I understand Damon and Sarah were part of. So it's a ongoing historical attempt to save the forests. And through it, we learned a lot about the legal complexities, and we're working with a lawyer now who's gathering those documents for us for publication. We're working with Bill Jones, who's one of the elders. He's pictured, we're showing the edit in an Oculus Rift to echo what it would look like in an IMAX theater. So do you want to?
Sure. What you saw before is when we showed them in the previous slide. That is Bill Jones, elder of Pachita First Nation, and the chief that I'm speaking with. After we showed them the project, we were able to get text from them so that we put at the end of the film, which created a very nice collaboration with them. And we're still working with Bill Jones on a booklet that we have been doing with him. Should I talk about this? Yeah, sure. So in 2019, we had the aerial was part of Outer Worlds, which is 5 short IMAX films, which is where we got the funding to make aerial. Then I think we can show you.
Give it
your
a try,
guess?
see what happens.
Okay. I just wanted to set up the clip. You're going to see the bridge that the protest built by
And it's a lot smoother normally. Thank you.
Great, thank you for that. So we'll move on to Katya, and then we'll take another pause for questions after Katya's presentation.
All right. C'est bon, OK. Bonjour, donc je m'appelle Katia. Je suis une étudiante à la maîtrise à McGill sous la supervision de Catherine Potvin. Et ma thèse porte sur faire le pont, la théorie et l'action, séquestration de carbone et reboisement en contexte communautaire. Donc spécifiquement, je travaille au Panama dans une communauté ou 2 communautés autochtones, Ipeti et Piriati Mbera. Et il y a 15 ans, ces communautés se sont engagées dans un projet de reforestation avec le Smithsonian Tropical Research Institute. Puis ce projet a été financé par des crédits carbone. Donc, le projet a l'objectif de compenser 3600 tonnes de CO2 en 25 ans. Donc, il y avait une vingtaine de participants qui ont chacun reforesté sur une parcelle sur leur terre. Il y a 36 espèces d'arbres fruitières et indigènes, 4 différents types de reforestation. Donc, j'ai analysé un peu tout ça, mais aujourd'hui, je vais me concentrer un peu sur de voir après 10 ans où est-ce qu'on est dans nos objectifs. Est-ce qu'on atteint les objectifs carbone? Oui, non, pourquoi? Puis aussi, c'est quoi les objectifs pour différentes personnes? Donc, un peu plus sur la perspective des différents acteurs. Donc, en fait, si on voit ici un peu à gauche, qu'en fait, non, on n'est pas en train d'atteindre nos objectifs généralement. On est environ 51% de ce qu'on aurait voulu avoir après 10 ans. Une grande partie du manque est due au feu. Donc, ça, c'est vraiment causé généralement par l'agriculture, puis qui brûle les forêts, en fait, qui repoussent. Puis on peut voir aussi un peu dans le graphique de droite que bon, les plantations qui étaient seulement des espèces indigènes avec un gros potentiel de séquestration de carbone, oui, sont en ligne pour atteindre leurs objectifs, mais les plantations agroforestières ne le sont pas. Donc là, on peut demander un peu pourquoi. Puis ici, c'est où est-ce que c'est intéressant de rentrer un peu dans les perspectives des différents acteurs, donc l'acheteur ou la communauté. Puis on s'est rendu compte qu'en fait, les estimés, disons, pour l'agroforesterie, de combien de carbone ça pourrait stocker, c'était fait sur des plantations agroforestières traditionnelles qui avaient beaucoup de gros arbres fruitiers comme des mangues ou des avocats ou une grande diversité d'arbres, mais qui n'ont pas nécessairement un si bon comme potentiel commercial. Alors qu'en pratique, quand ils ont reforesté, ils ont planté beaucoup d'arbres de café qui ont un bon potentiel commercial, mais c'est vraiment des arbustes, ça ne store aucun carbone. Donc là, c'est un peu, justement, c'est quoi l'objectif? Donc, si on optimise pour le carbone ou est-ce qu'on optimise pour la sécurité alimentaire, économique? Une autre observation qui était intéressante, c'est vraiment la longévité du problème. Donc, reforester, bon, tu plantes les arbres, OK, c'est bon, compenser le carbone, mais c'est 25 ans de travail et d'entretien pour que le carbone soit vraiment stocké dans les arbres. Puis ça, justement, comme par le feu, qui est un risque qui continue à travers le temps indéfiniment. Une dernière chose qui était intéressante, c'était un peu les jugements de valeur. Donc, c'est quoi qui est de valeur? Donc, par exemple, le reboisement naturel, la repousse naturelle avait une vraiment bonne contribution au budget carbone. Fait que d'un côté biodiversité, un côté de coût d'installation, puis carbone, mais ça c'est vraiment une perspective intéressante. Puis là, la communauté nous disait, ouais, mais on veut pas ces arbres-là, nous, comme c'est la repousse naturelle, on en a partout. Ce qu'on valorise dans ce projet-là, c'est qu'on ait des espèces qu'on n'a plus sur notre territoire. On veut des espèces spécifiques, on veut des espèces qui sont utiles un peu, qu'on ait une valeur culturelle. Donc, ça, c'était juste plusieurs perspectives un peu intéressantes. Puis tout ça, ça sert, c'est un projet de recherche-action participative, donc ça va servir à informer maintenant la prochaine itération du projet. Donc, la communauté a signé un contrat avec McGill pour un nouveau projet de reforestation. Puis, entre autres, là, une des nouvelles qu'on a eues, c'est que le Smithsonian Tropical Research Institute et la communauté sont en train de renégocier un contrat pour le paiement pour les 15 prochaines années, considérant les données sur le feu et tout ça. Donc, voilà. Merci.
Merci, Katia. OK, so on prend une deuxième pause pour quelques questions, s'il y en a. If anyone has any questions for any of the recent presenters.
If you guys have a question, I encourage you to go up to the mic at the podium, please. Thank you.
J'avais une question pour Katia. Comment on décide la valeur d'une unité de carbone? C'est le Smithsonian qui a donné ce montant-là? Ou d'où ça vient le montant d'argent qui va être payé?
Oui, bonne question. Donc, le prix du carbone, en fait, ça vient d'une négociation qu'ils ont eu entre la communauté et le Smithsonian. Donc, c'est comme un marché volontaire, en fait. Donc, ils auraient pu mettre le montant qu'ils voulaient. Donc, ça a été négocié en 2008. Puis, à ce moment-là, ils ont mis une valeur de 10 $ la tonne. Maintenant, disons, le Smithsonian, dans ses nouveaux projets, ils font comme 22 $ la tonne, quelque chose comme ça. Fait que c'est pour ça aussi que quand... là, ça fait 15 ans, mais le projet, c'était comme les pionniers du premier projet. Puis là, la question, c'est, OK, mais est-ce que eux, leur prix de carbone est beaucoup plus bas, puis c'est encore pour un autre 15 ans? C'est pour ça qu'ils ont comme accepté de renégocier, mais c'était une négociation entre la communauté et Smithsonian, puis les deux sont accordés que c'était un prix raisonnable. C'était aussi un prix qui couvrait beaucoup des coûts d'entretien, donc dans les premières années pour planter, pour arroser, pour nettoyer les parcelles. Donc, comme le prix est un peu basé sur ce que ça prendrait pour l'entretien dans les premières années.
Any other questions? Yeah. Yeah.
I have a question about the FSC project. So my understanding is you're looking more at the procedural aspects of implementation to investigate outcomes. And I'm curious as to whether you're looking at the process by which FSC determined how to, I think you called it AFPIC, how they integrated and thought about AFPIC, because I imagine many of their stakeholders and investors are corporations. And so I'm curious as to who was at the table and how they informed that process by which it would be implemented, and if you're looking at that.
So I think what you're speaking to in some ways is like the governance of FSC. And yeah, we looked at that too. We didn't look at the process by which they decided, yes, we're going to integrate FPIC into the standard, but I can kind of extrapolate a little bit based on knowing how FSC works. And they have a very, I would say like a deliberate governance process, which is based on these three chambers: social, environmental, economic. In Canada, they have a fourth chamber, which is Aboriginal, and that's a unique feature of FSC Canada. But at the international level, they have the three chambers. They also have a global north and a global south chamber. And so they're always trying to have some type of equity in decision-making by weighing the different chambers in an equal manner and forcing the chambers to negotiate and find consensus amongst them before making decisions at every single level. So when they revised the new standard, which is what led to FPIC, they at every level, international and then national, the different chambers needed to come to agreement about what was going to go into the standard. And so I assume that there was a decision consensually that FPIC was the way to go in terms of Indigenous requirements. And what you see in some of the other standards, because ever since FSC came around, there's also kind of more industry-led standards which have popped up all over the world. And those standards tend to kind of stick with like the consultation and accommodation approach to respecting Indigenous rights, which is, you could say maybe it's sort of one step less strong than what FSC has decided to do. On the other hand, I would say, like, if I were to tell you like one of the main conclusions of the study, which I think is pretty interesting, it's that FSC has the limitation that it's really oriented towards forest management and not political governance, which is really what FPIC was created to be. And so what we're seeing when we look at that first stage of research is that, in fact, the way that it's being interpreted is watering it down because it only really has jurisdiction around forest management stuff and not, political negotiation. And so there's a tendency, it's straying towards, okay, well, all we have jurisdiction over are decisions, maybe more operational decisions around forest management. We're not going to be able to resolve broader political disputes and issues of kind of land authority and jurisdiction. So that's maybe the disappointing result of that research.
Any last questions? Okay, why don't we move on to the last set of presentations? So first I have Rylan. Rylan with an L, sorry. No, you're not presenting, don't worry. Next year.
Hello, I'm Rylan. I'm a PhD student at McGill University in Jeff Cardill's lab. And most of my research focuses on creating maps of historical forest disturbances using deep learning. So forest disturbances continue to impact forests for many decades after they occur. And because of this, if we want to truly understand the current state of the forest, we need to include the disturbance history of that forest, looking as far back as possible. And the easiest way to do this over large areas is with satellite-based remote sensing. And because we want to look as far back in the history as possible, that means we use Landsat satellite data. Landsat is the first satellite-based Earth observation program, and it goes as far back as 1972 and continues to today. And despite the fact that we have this satellite data going back to 1972, most historical analysis based on this satellite data only look as far back as 1985. And the reason for this is that that first decade of data comes from the Landsat multispectral scanner, which is their first generation sensor. And using that data in comparison to the modern data is incredibly difficult. Each of the Landsat MSS pixels contains less information than the modern pixels, covers a larger area on the ground, and the measurements that it makes are less precise. On top of that, there's also just less MSS images in comparison to Landsat today. As well, if you're making maps today, you don't just have to use Landsat, you can use all the other satellites that are operating. And so the goal of my work is to say, we have this decade of data that essentially no one is using. Can we extract useful information from that data to map historical forest disturbances? And to overcome these limitations, I use deep learning. The goal with the reason for using deep learning is that these algorithms can exploit spatial relationships among pixels instead of just using the information within a single pixel. And so because there's such little information in each MSS pixel, if we use all the surrounding pixels, we can potentially create a better result. And so up to this point, I've created maps of forest fires in Quebec in the 1970s. And when we compare the maps that I made to the existing best maps of fires during this time period, we find that the existing best maps underestimate the total burned area by 35%. And so this tells us that yes, we can extract information from MSS data using deep learning, and that there's new information in that data that we can't get anywhere else. And so right now and for the foreseeable future, I'm working on expanding those maps to the rest of forest-dominated Canada and including other disturbance types such as harvest. Thank you.
Thank you, Rylan. Next up, we have Antoine.
Okay. Well, hi, everyone. My name is Antoine Lachance, and I work with Janine Marie Saint-Jacques at Concordia and Matthew Paris at Bishop University in Sherbrooke. And my thesis focusing on using ambrotrophic peat bugs to study the history of climate and storms on the Magdalen Island in eastern Canada over the period of the late Holocene. And so the basic idea behind using peat bug for studying old storm is that when there's a storm happening, the strong winds will transport material either in the form of sea spray particles or aeolian sand, and it will transport this material further inland in peat bogs, for example, where they will accumulate over time. And so ambrotrophic peat bugs are very useful to study old storm because they receive water and minerals only through atmospheric processes. And so the goal is to take a core in the peat bog and then look at those layers where we see a peak in aeolian sand or in sea spray, and to date those layers and to construct a reconstruction of storm. And so 2 years ago, we went on the Magdalen Island and we took 2 cores from 2 different sites, TAC and TLM. And first we dated those core with carbon-14, lead-210. So we know that they are about 4,000 years old. And our hypothesis as to how we would detect storminess in the core was that it should be expressed by short-term variation in terrigenous elements present on the beach on the Magdalen Island, like titanium, potassium, zirconium, and it should also be expressed by short-term variation in the aeolian sand present in the core. And so we did analyze the core, we did do the geochemical profile with an eye-track scanner, and then we burned the peat every centimeter to get the mineral fraction and then the aeolian sand fraction of the core. And so these are the results of the storm reconstruction. So in the end, we decided that using aeolian sand and titanium concentration in the core was the best combination to find where the storm layers are. So after normalizing the titanium concentration and then applying a threshold to this data, we found in both cores, so TAC and TLM, we found 7 layers or event beds in the last 1,000 years that corresponds to each other in both cores. When we look at panel C, so event per century, we notice that there's 2 times in the last millennium where there was more storms. So first was in the last 200 years, but we're not sure if it's because of landscape change on the Magdalene Island, like road building. But what's interesting is the increase in storm between the 15th century and 1650. And this is an interesting result because it also has been recorded at 4 different sites in the North Atlantic. So in panel C, we see one of those sites in Salt Pond in Massachusetts. So that's an interesting result coming out of this research because we know that the process affecting storm variability in lower latitudes such as the Bahamas or New England also have impact as high up as the northern latitudes where the Magdalene Islands are found. And so that's a cool result because our study is the most northern storm reconstruction in the Gulf of St. Lawrence, in North America, I mean. And so I'll be continuing to do this research for my PhD, but in other sites throughout Eastern Canada to build this network of reconstruction. Thank you.
Great, merci Antoine. Next up is Shannon, who is another new collaborator with the LEADS program. So she's going to tell us a little bit about her.
I don't have slides. Good morning, everyone. I'm a professor here in management. Also have an affiliate appointment in industrial engineering. So I work with students in both management, industrial engineering, and other disciplines as well. So I'm going to talk a little bit about 2 areas of research in my group that I think might be interesting to all of you. So first, my work is grounded really in life cycle assessment, risk assessment, and greenhouse gas accounting. And so I'm going to start with some of the work in life cycle assessment. So this is a framework for assessing the potential impacts of products from cradle to grave. And it really takes a very static perspective, using mostly aggregate data. So we would look at a specific type of process. We may have some primary data for that process, or we may have some secondary data. Surely for the supply chain leading up to the processes that we're interested in, we're using secondary data. And this often is based on average data for some geographical area over some time. And many of the environmental impact categories that we look at, for the most part, the impacts depend on where and when the emissions occur, the resources are extracted. And so some of my research is focused on integrating the spatial and temporal information into LCA so that we can have a better understanding of the potential impacts and more closely link it to risk assessment, where we're looking at, well, what do we think the risks are associated with this product? And I think this is increasingly important as studies done using LCA are used to inform policy and other important decisions. The other area it's actually quite closely related to LCA is greenhouse gas accounting. And my focus is really on indirect Scope 2 and Scope 3 emissions. From a Scope 3 perspective, I focus primarily on supply chain emissions. And we've done a number of studies recently looking at companies that report their emissions to CDP and looking at the methods that they use to estimate their Scope 3 emissions. And it really relies heavily on LCA. So a lot of the emission factors, for example, are built using LCA. So they represent industry averages, often for a different geographical location than the company is located. And so my research now is moving in a direction to think about, well, how do we change that? How do we leverage the variety of data sources that are available and information technology tools that are available to bring more specificity where it is needed. And what I mean by that is a lot of the supply chain emissions aren't that actionable. And so, and also some of them are relatively small compared to other areas. And so we want to identify is where are the big emissions in the supply chains for different industries, and how can we do a better job of identifying where those emissions are occurring and how big they are to enable action. I think that wraps it up. So if you have any questions, I'm happy to answer.
Thank you, Shannon. Look forward to your participation in the program this year and moving forward. So we have 2 more presentations before we take our last set of questions. Next up is Charlotte.
Okay. Hi, everyone. It's really nice to be here with you today. My name is Charlotte, and I'm doing my master's just across the road here in a geography lab. I'm supervised by Janine Marie St. Jacques and Matthew Peros, who is at Bishop's. So my master's is reconstructing a vegetation and climate record at Lanceau Meadows in Newfoundland. This site is most well known for being the only Norse settlement in North America that's been found yet, but it also has over 5,000 years of indigenous archaeology there. So it's got quite a bit of human disturbance, which I'm very interested in. So here you can see the site. It's at the very tip of Newfoundland, and this is a reconstruction of what one of the Norse buildings is thought to have looked like. So I'm doing this through lake sediment cores, and the idea behind this is that microparticles in the atmosphere, like pollen or microcharcoal, settles into lake surfaces and then eventually sinks to the bottom where it's preserved in the lake mud. So we go out and we get this lake mud by a very complex, labor-intense method, and we bring it back to the lab, and I sample it for pollen and a couple other geochemical factors. So we went out in August of this year. It took a lot of work to get out there. We drove for 31 hours in a Dodge Caravan with about a metric ton of equipment with us. This is what the houses looked like when we were there. We were there for about a week, and we thought we were going to do about a lake a day. We did not get anywhere near that. I learned a lot about what lake core sediments actually take to get them, and it's a lot of hauling equipment across bogs, and then you get to the lake and it's not good enough, and so you have to find another one. But it was really fun. So this is the first lake we did. It was far too small and not deep enough. It was only 1.5 feet deep, so these people could have just walked off of the boat, but they didn't. But we were there anyway, and we had to practice, so we made our little raft, which you can see there, where that's the least amount of equipment we used the whole trip. And then this is 3 days later, we finally found a lake that worked. It was deep enough, and it had an organic bottom, which is what you need, because sand destroys pollen too quickly. So this is us trying not to sink ourselves and all of our equipment on this lake. But we finally got, I think we got about 3 meters of core this day, so we were very pleased with ourselves. And then the last day we were out there, we decided to do a peat bog, which is what my colleague Antoine works on. So this is how you get them. We were in this very wet bog, and one of our professors went in the bog, and we had to haul her out very quickly. So yeah, that is what my fieldwork looks like, and I'll be analyzing the core for the next 2 years and looking at the vegetation. Thank you.
Great, thank you. Okay, moving on to our last presentation. Gabby, I think, is here somewhere. Yes, good.
Hello. Right, I'm Gabby, and I'm going to be talking a little bit about my research today. I'm a PhD student at McGill and Mila, looking at machine learning for agriculture. So I look at how machine learning can be helpful to better understand agricultural practices and also to help us build more resilient agricultural systems. This is relevant to a range of stakeholders, all the way from the farmers to the governments who might want to design policy based on how agriculture is happening in their country. Okay, why is machine learning an interesting tool to investigate it all here? The most compelling reason is that we collect a lot of data about the planet. So this is an image from Maxar. They collect images of the Earth at 30 centimeter resolution, and they do this 15 times every day. So 15 images of the Earth at a 30 centimeter resolution every day. So this is way more data than a human could reasonably ingest, but it gives us an opportunity to really deeply understand what agricultural practices look like around the world and how they're impacting the planet. And this quickly translates to real-world impact. So in 2020, the Togolese government wanted to provide interest-free loans to farmers to support them through the COVID-19 pandemic, but it didn't know how agriculture was happening in the country, and therefore how those funds for the loans should be spatially distributed. So I was part of a team which developed a cropland map for them, which ultimately informed the deployment of interest-free agricultural loans to over 57,000 farmers in Togo. Cool. On the other end of the spectrum, farmers themselves care about much smaller scale outcomes than governments. They might care about how a specific plant is doing, or whether there are lots of weeds in one corner of the field. The data collection process here looks a bit different. Instead of satellites, we use robots. And the example here is from the small robot company's Tom robot. And these robots are used to collect extremely high resolution images of a field. And then we'll use machine learning to figure out where the wheat plants in the image are and where the weeds are. Understanding the field at such a granular level also yields a bunch of benefits. So for instance, it allows for non-chemical weeding, since instead of pouring herbicide over the entire field, we can send in a second robot to kill individual weeds with electric current. So this has huge environmental benefits, and it also saves the farmers a bunch of money. So in all of these cases, we need two inputs to train our machine learning models. Some input from a sensor, we call that X, so it might come from the satellite or the robot, and then some label or desired output from the model for that X, and we call that Y. The trouble is, these labels are super challenging to acquire. So for instance, knowing if some point on Earth is growing maize requires sending someone to that point, and this is expensive, time-consuming, and in some cases impossible or very dangerous if there's conflict happening there. So while we have plentiful satellite data, we're often dealing with very few labels. And for example, when we were creating this map in Togo, when we started out, we only had 58 labeled points with which to train our models. So a lot of my research investigates how we can make the most use of the few labels we have. Right, to summarize, we collect lots of data which might help us better understand agriculture around the world, but we're limited by a lack of labeled data. And machine learning can help us here, but we need to specifically investigate low data methods, machine learning methods suitable for agricultural contexts. And that's it. Thanks.
Okay, so let's have a few questions for the last set of presenters. Yeah, Eliane, so maybe just step up to the microphone and ask your question.
This question is for Gabby. Just wanted to know the last part of your research, was that also done in Togo? And I also just didn't hear who are your supervisors on this project?
I'm supervised by Professor David Rolnick at McGill, but I also work closely with Professor Hannah Kerner. She's of the NASA Harvest Project. And then my research, so a lot of machine learning research is global in scope, and we hope to develop tools that will be useful generally, but we try and motivate it by like context-specific use cases. So the research we did in Togo, we're now applying it to other places, such as, well, many other countries, but it was originally motivated by this problem in Togo and developed in a Togolese context.
Gabby 2.0 here. So my question is about technology, and I know this goes beyond your research, but I'd be curious about what you think about it. So I actually grew up on a farm. My family still operates one of the few family farms in the county where I grew up, and most of the rest of the farms have been corporatized. And so, what we've seen is that as technology has advanced, those who have the capital to procure that technology reap the benefits of the technology. And so the question I have, again, I know this is beyond your research, but I'd like to hear your thoughts about that in terms of, so I see the robot technology, and then this is what I think is those who can afford that are going to benefit from it in the future. And so I guess just, your thoughts generally on the ability to, provide this technology for, farmers throughout the world who have, small family farms that they'd like to continue to have.
Cool. I definitely recognize that's a problem, and I don't have the solutions, but So for the small robot company, which was that specific example, they work mostly with relatively small farms in the south of England, and the model that they have is they basically allow farms to create what they call pods. So they'll have 30 farms that work together to lease one of the robots. And so it's definitely a problem, but hopefully some people are thinking about solutions as well.
Any other questions? Yeah, come on up.
This might be a naive question. For all the people who are doing paleo research, so Fatima and Antoine and Charlotte, and for Rylan and Gabby, like, I understand that the paleo research is thousands of years ago, and I understand that Rylan, you're looking at like from the 1970s forward. Like, is it of interest, and is it possible to apply like Rylan's techniques and like the machine learning that Gabby does to the data that you're collecting from your core samples, like from thousands of years ago? Like, is there an interest in somehow using like Rylan's technique with the data that the people are collecting when you're physically going out and collecting your samples to understand what happened thousands of years ago? I don't know if that's a naive question, but it struck me as interesting that you have like history from paleo times and historical data in terms of the way that Rylan presented it, and these two methods, which is one is like very physical and one is looking at like pictures of the earth that we get, 15 times a day. And is there a way to bring those together, and is it of interest to do that? And maybe that's I don't know who can answer.
No, it's a good question. Does anyone want to take a stab at it? Yeah, jump up to the microphone.
I mean, I can speak for my specific research, which is on storm, and it's true that it's so in the past, and sometimes we think it's a bit not very useful. But actually, for example, we know in extreme weather events, we know more or less that there's going to be more heat events in the future, more precipitation, the droughts are going to be longer. But for storm, there's a lot of uncertainty about change in intensity and change in the storm track position and which area are going to be more or less affected. And the data for storm only go back to the satellite era data, so the 1970s at best. So using this paleo tempestology data actually helps us kind of extending the instrumental data further back in the past. And that helps us also understand or analyzing change in storm in relation to the climate, which also changes on longer timescale, like 30 years or centennial timescale. So then I guess, I'm not working on that, but I guess there's probably a way to kind of integrate this data to the modeling data and make the model a bit stronger by having a longer time span of real data to feed into the model. But that's just for me. But I guess it's a bit the same for all of the paleo data, especially with regards to extreme events. It just helps pushing further back the instrumental data.
Yeah, I mean, there's something in like how you combine this long time series with current observations and whether it can kind of contribute to this need for more labels that Gabby was talking about. Yeah, does anyone else want to comment on that question? Fatima, you look like you are almost wanting to speak.
Okay. I can add to what Antoine said. Regarding the techniques, of course, techniques and like machine learning and like developing a model that can, for example, in my research can use the data. For example, my research is like, we hopefully get frequencies, flat frequencies, past flat frequency, but if we could like get intensity, so it was something that we could like be happy about that. And like, so the techniques that Rylan and Gabby and like they will like making, developing a model that can like training a model that can gives us like, because we paleo people we can have like a longer record. So I guess like these longer records can help us to have if we can train a model based on them, and like they are like we can like trust them 100%. We can like have a better prediction of the future and what's, for example, in my research, what the floods in the future look like. So that's what I would add. Thank you.
Yeah, so something about using time histories as a substitute for spatial observations might be interesting to look into. Any other questions? No, yes. Okay, I think we're in good time. We have some lunch that I believe has arrived over on the side of the room. So I think we'll close the formal event. Those of you who are on Zoom, we'll have to say goodbye and you don't get to share the food, unfortunately, but I would invite you to go and have lunch. Those of you who are in the room, feel free to mingle and continue the discussion as long as you like. We need to be out of here by about 12:30, 12:45 or so. So thank you, everybody, and I'll turn it back over to Anna, maybe to close the event.
It's actually going to be me over here. I'm just going to say thank you so much for joining us today. So like Damon had said, we're going to go ahead, close up the Zoom, stop the live stream. Just a reminder that we were streaming live to YouTube, so it will be uploaded immediately after this, so you can rewatch it. So go ahead, get some lunch, and thank you so much for joining us.